Right, folks, what I have here is a situation where I need to know the concentration of a base. I had a student who indicated that this was NaOH, sodium hydroxide, so that's wonderful, but I have no idea how strong this is. It's always important, if you take a look at this acid, HCl, it's got a 3.0 big M indicator on that, so I know how strong this is. And that's very important. And if I don't know the strength of a base, I can actually figure it out using some volumes as well as this particular acid, knowing that it's 3.0. You could use any acid to figure out a base, but you're going to be dealing with different numbers. So I'm going to use an indicator solution. An indicator solution is going to indicate if it's an acid or a base. So there is indicator solutions where I have a card like this that tells me that if I have a red, orange color, it's an acid. If I have a blue, greenish color, it's a base. If I have a 7, it's going to be kind of a light green. That's good if I want to know varying degrees. Here's my sodium hydroxide. I'm going to put some of that solution in, and you can see it's kind of pretty dark green. That's good. I like it. For this application, I'm not going to use it though. I'm going to use something else called phenolphthalein. All right, phenolphthalein kind of looks like this. It's clear. All right, and you're going to say, well, how is a clear solution going to help you? Well, if I take that sodium hydroxide again, and this time I have it in my graduated cylinder here, and I put a couple of drops in, all right, well, it's now changed that clear liquid, both of the sodium hydroxide and the phenolphthalein, to this magenta pink color, all right, and that's very important. So if I drop some, if I have a base and I put phenolphthalein in, then I know if this magenta color comes up, I've got a base color. So the question is, well, what happens if I have an acid and I want to try the same thing? Well, here's my acid now. Again, hydrochloric acid, I know the concentration of this is 3.0. Let's take a look and see what happens when I put some of that phenolphthalein in. Absolutely nothing. It's clear. So clear with an acid, magenta pink when there's a base. So I want to know at that point, right where it goes from magenta to clear, that must have been the point where I went over from a base, magenta, to clear an acid with one drop. And I'm going to use something called a titration to do this. So the titration that I'm using to do this is this, kind of elaborate setup that I have up in front of me. And I'll show you. And it looks like this, right? It's a stand. It's got a top that I had a funnel. I put some of that 3.0 HCl in. I filled it all the way up to, it looks like 32 exactly. It's got a nice graduation to it, the smaller numbers towards the top, the larger numbers toward the bottom. What I really care about is the difference between what I start with, in this case 32.0, and what I end with in terms of drop by drop into this Erlenmeyer flask. Right now there's nothing in an Erlenmeyer flask, so I'm going to add exactly 10 milliliters of that unknown sodium hydroxide in here. And to this 10 milliliters, I'm going to put some of that phenolphthalein. And that should turn, not surprisingly, this solution to that magenta color. So I just need a couple of drops in there. Okay. So there we go. We know we have a base there. So there's my sodium hydroxide. Remember, in this burette, I have my hydrochloric acid, and it's 3.0 molar. And I know the volume that I'm going to be dripping into this. Again, I have right now 32.0. I want to see what I have in the end. So if I open this up, it's going to go drop by drop. All right, drop by drop in there. And I'm going to swish it around, still magenta in color. I'm down to about 34. I'm down to about 35. So it goes down pretty quickly, even though this looks like drop by drop, it's going to take a long time. So remember, I had 32.0 in here. And you notice it's still pretty strong. So I'm going to slow my drops down because what I want to know exactly at that last drop, right? Maybe I'm going to go off to the side now. Here, how about that? Right, so now you see, so drop by drop now. Got to be very careful. Opening it up, opening it up, opening it up. Right, and there we go. I'm going to go drop by drop. So you notice it got clear pretty quickly. So there was one drop. All right, so I must be at that threshold where I'm almost at the point of where we have a base that's going to an acid. Maybe I'll go just a little bit quicker. All right, drop by drop. A bit too much. All right, still pretty magenta looking. There's one drop. There's another drop. There's another drop. All right, I'm down to about 38.5. Remember, I started at 32.0. Okay, drop by drop. You notice right where it goes in, too, there's a real kind of contrasting colors. And that's what I'm going to look for. Right where it drops in, remember, is going to be where it's most concentrated with hydrochloric acid. And it's going to look clear right where that drop goes in. And that's going to be the indication to me that, hey, I got to stop and it may be another drop or two. All right, so because every time I swish it around, I'm actually spreading out the hydrochloric acid and dissipating it and allowing it to react with the sodium hydroxide. Remember, what am I making here? I'm making pretty much salt water. The sodium and the chloride makes the salt, and then the acid and the base, the H and the OH, make my water. So I'm pretty much making a fairly unreactive, simple saltwater solution. So it's going drop by drop. I'm at about 39 right now, 39.2. I don't know if you saw that there, but right where it kind of went in, it was clear. Yeah, so it's clear right where it goes in. So I'm getting close, getting close. So I'm now below. I'm at 40.5. Remember, it goes up. I'll just have to do a quick calculation to figure out the volume that we put in here. We know the volume of the sodium hydroxide. We're going to know the volume of the hydrochloric acid that we put in. And we know the molarity of the acid. So the only thing that we don't know is the molarity of the NaOH. And that's key here. So it's very much like our M1V1 kind of problem. But with an acid and a base, knowing how many hydrogens and how many hydroxides based on its formula is kind of important here. So let's see, we're getting there. I'm at 41.5. And you notice how it got lighter, it got darker, but it's still basic in solution. That acid's working on those hydroxides and turning them into water, but there's still hydroxides in there overall. All right, so right where that drop went in, it was kind of clear. It's clear, so we're getting close. It's clear, it dissipates some of that H, finds some OHs, and it's still hydroxide, still a hydroxide, still too many hydroxides in there. We're getting close. Really clear right there, really clear right there. So if I'm not swishing it, there's a real strong concentration of hydrochloric acid right where those drops go in, and then it's going to dissipate because those molecules, they're liquid, just like a gas, they float around fairly freely. These float around freely, just not as free. There you go. So that last drop there, I'm at 42 point, looks like 1 to about 42.3. So I started at 32 and I'm at 42.3. So we'll do the subtraction, we'll do the calculation together. There's your titration. Liquid is clear.